Welcome friends. Let us continue to study heat engines on my YouTube channel. Kindly like, share and subscribe my YouTube channel. The topics included in today's lecture are air standard cycles and terminology related to reciprocating engine. Air standard cycles. Otto cycle and diesel cycles are considered as air standard cycle. All petrol engines works on Otto cycle and all diesel engines works on diesel cycle. Now we know that petrol and diesel are used as a fuel in petrol and diesel engines or a petrol and diesel vehicles. So in petrol engine, mixture of petrol and air is working as a working medium or a working fluid, while in diesel engine, mixture of diesel and air is the working medium or a working fluid. But for the theoretical analysis, only air is considered as working medium in Otto and diesel cycle. So for theoretical analysis, that is for the theoretical calculation and deriving the equation of work done and efficiency of petrol engine or diesel engine, that is the Otto cycle and diesel cycle, we consider only air as a working medium instead of mixture of air and fuel. And therefore, it is known as the air standard cycles. Now the assumptions which make the cycles air standard, that is the air standard assumptions. The working fluid is air which is continuously circulates in a closed loop and always behaves as an ideal gas. So that is the one assumption for the air standard cycle. All the processes of the cycle are reversible. Specific heat of air remains constant. The combustion process is replaced by heat addition process from an external source. Now let us see what is combustion process. So in a combustion process, air and fuel enters, and in presence of air, fuel burns and energy is generated, and the combustion products now enters or that works into the engine. That is known as the combustion process. But for air standard assumptions, this combustion process is replaced by heat addition. Now what is heat addition? Only air enters into the heating section and heat is supplied from the outside, and heated air now works into the engine. So that is known as the, you can say, heat addition process, and that is one of the assumptions in air standard cycle. Terminology related to the reciprocating engine. Dead center. Now let us see, this one is a cylinder. This one is a cylinder head portion in which inlet and exhaust valve are located. This one is a piston, and we know that piston reciprocates from left hand side to right hand side or right hand side to left hand side. And the extreme position of piston is known as the dead center. And that at that extreme position, piston stops for fraction of second and changes its direction. So that is nothing but the dead center. So dead center, it is nothing but the extreme position of a piston in a cylinder. So this is the extreme position, and that is known as the dead center. And here that was another extreme position of piston, that was again the dead center. So in a horizontal reciprocating engine, dead centers are known as IDC and ODC. That is a inner dead center and outer dead center. The dead center nearer to the cylinder head is known as the inner dead center, that is IDC, and opposite to that it is known as the outer dead center, ODC. In a vertical reciprocating engine, dead centers are known as the top dead center and bottom dead center. So this one is a vertical cylinder engine in which this is the topmost position of piston, and it is known as the top dead center. And this one is the bottommost position of a piston, and due to that it is known as the bottom dead center. Stroke length. Consider piston was at IDC. Now the piston is moving from IDC to ODC. That is the outer dead center. So the distance travelled by piston from one dead center to another dead center is known as stroke length. So when piston moves from one dead center to another dead center, in this case IDC to ODC, and that distance is known as the stroke length, and it is denoted by the capital L. Clearance length, LC. Now consider piston is at IDC, that is this the position. Now you look at this position. At this position, piston is not in direct contact with the cylinder head, or there is a gap between the piston and cylinder head, and that gap is known as the clearance length. So there is a gap between piston when piston is at IDC and cylinder head, and that gap is known as the clearance length. Now why that gap is provided? This gap is provided so that the inlet and exhaust valve can open properly and there is no direct collision between piston and cylinder head or piston and valve. Area of cylinder, or it is also known as the area of piston, denoted by the capital A, and it can be calculated using the equation area is equals to pi by 4 d square, where capital D is inside diameter of cylinder, or it can be the outside diameter of piston, or it is also written as cylinder bore in the different numericals. Stroke volume or a swept volume, and the symbol is Vs. And we can calculate the stroke volume or a swept volume using the equation Vs is equals to area multiplied by stroke length, that is capital L. Clearance volume, Vc. It can be calculated using the equation Vc is equals to area multiplied by clearance length, that is Lc. And the total volume of cylinder, Vt, that is equals to Vs plus Vc. Compression ratio, R. Compression ratio is defined as the ratio of total volume of cylinder to clearance volume, and R is equals to V total divided by Vc. Kindly ask your queries in the comment box. Kindly like, share and subscribe my YouTube channel. Thank you.